Good afternoon, dear participants. Welcome to the afternoon session of our FDP short-term training program on big data, machine learning, paradigm shift. I'm happy to introduce the speaker for the afternoon session, Mr.SasiKumar Venkatesh, Senior Software Engineer from Walmart Global Tech India. Prior to joining Walmart, he has an experience of working with the companies such as Matizalin Technologies, Coda Global, and Top Freshers Technologies. So most recent experience has been to working with a startup called Matizalin Technology, where he was responsible for architecting, building, and deploying the product called Nura AI, a unified data analysis platform. So his skills and proficiencies are Java, Springs, microservices, data warehousing, Apache Spark, big data, and machine learning. So Mr. SasiKumar has done his Masters of Engineering in Computer Science from SSN College of Engineering, Chennai, and received gold medal for academics and internships. His other hobbies include cooking and playing tennis, and hobbies are exploring open source technologies, teaching computer science. On behalf of the Department of Computer Science and Engineering, I extend a warm welcome to you, sir. Over to you, sir.
Thank you, ma'am, and a very good afternoon to one and all present here. I'm very excited to be part of this FTP to deliver a session on H2O flow and sparkling water on how to do data analysis for time series data. So I'm very excited, really, because after a hectic work schedule, like it's been like continuous Zoom meetings, but like in this meeting, like I am talking, but at the same time I'm also sharing my knowledge. So that is a very intriguing part for me. So I think I'm excited. So maybe let's get started. Yes, ma'am. Shall I proceed, ma'am?
Yes, please, sir. Yes, please.
Okay. Hope. Okay, let me share my screen and we can go through what is this. So to give a background about what is H2O, right? So I'll tell you about what is agenda of today's session. So today, my agenda over here is, so I'll introduce a little bit more about myself. I am a SasiKumar working as a senior software engineer at Walmart Labs. So the scale of data in which we deal with every day at Walmart is very huge, tremendous. In terms like even the streaming data comes as a terabytes of size, and we use that data to process and to do real-time machine learning and deep learning analysis on the fly, because our business rely on that. So to do such intense data intensive applications, so my responsibility is to create a platform which is scalable and which is more compatible to run like a huge amounts of data workloads in terms of ETL or in terms of data analysis at Walmart. So that is my spectrum of work I'm doing at Walmart. So coming to H2O, right? So what I'm going to teach you today is, so I'm going to introduce a framework called H2O, which is very open source, as well as which is actually leading in more of the data science field. So I'm going to give a session on something called H2O flow and how this overall H2O is designed. So now we know that, right? So machine learning and deep learning, these are like algorithms that are predefined. Predefined, I mean, like there are no new inventions are happening. It's happened already. So we are actually like, if you see the deep learning, the neural network and all those things, it has actually happened like 2 decades earlier. Okay, so we are making that algorithms practice now because we didn't have a compute capability and we didn't have an infrastructure to support that. But in today's modern hardware and software, we have that capability. We can actually bring in that concepts into use. So because of the recent like hardware and software advancements that are happened over the last decade. So just to give you an example, right? So I have a smartphone, okay? So that my smartphone itself has like 16 GB RAM, okay, and like 64 gigahertz of processor. The same has like my laptop. So I'm using a MacBook Pro, and my MacBook Pro also comes with a 16 GB RAM, but I have like 255 SSD drive. So like, why do you need like uh, a memory, 16 GB of memory? If you remember, like first time when NASA launched aircraft to moon, it actually gone with 64 kilobytes of RAM in that satellite. Okay, so that is that era. But now like I have 16 GB of RAM, so that much of hardware enhancements has happened in terms of both RAM, speed of your network. Like we have like this 4G, 5G still coming up. So all those things are add a lot of sense to our computation platforms. So that is the whole overall agenda of my session, which I'm going to take for next 1 hour or so, and with a demo, which will be included. So let's get started. So what is H2O? Okay, so H2O is first of all, it is actually a startup company, a company which is started like 2000 like 15 and above. So during that time period, and this H2O is actually like the H2O. So basically in chemistry we know H2O is a water. So like why they named it as a water, that is again an interesting story. So let's not get into that now. So basically if you see what is H2O, H2O is a framework, also a platform. So when I say a platform, it offers a math platform like our MATLAB kind of a software, where it is an open source in-memory prediction engine. And the way the math platform works, it actually works with a parallelized distributed algorithms, and we can utilize the multi-threaded cores that are available in our systems. So some of the algorithms that are very specific to H2O are GLM, random forest, GBM, PCA, etc. So all these machine learning algorithms that you can run on top of H2O. Not only this, there are many, but these are few examples. So like this is the first layer of H2O, which is a math platform. So the next to it is, right, so it is also comes with an API. So API, it's like a very programmable interface. Okay, so if you see, it is very easy to use and adapt, and it is completely written in Java and perfect for Java programmers. And so it also provides REST API to connect to other languages like R, Python, Tableau, etc. So you have a math platform, you have a easy usable API, but what is the data that you are going to deal with? So the data we are going to deal with is a large data, which is a big data. So what is the problem of running deep learning and machine learning on big data? Because big data itself is a problem because it has very large volume, velocity, variety, and verbosity. But when you bring all these V factors into machine learning also, because the way we deal with big data is we use distributed computation and distributed processing to analyze data faster for big data. So now we are going to use the same big data, and we want to perform additional machine learning and deep learning algorithms on top of your big data. So that creates an interesting problem. So like there we have a solution, which is H2O, which brings running machine learning and deep learning algorithms in a distributed fashion. So that is the nutshell of what is H2O. So H2O is a framework that offers a math platform and an API for a big data platform to run your machine learning and deep learning algorithms in a distributed fashion. So this is what H2O is. So let's see how does it look like. Okay, so if you see, right, so this is an example of an H2O, like a block diagram, where we actually have a lot of different data stored in different storage formats, different databases, etc., like HDFS, S3, SQL, NoSQL. So these are different data formats and different data store types that are being stored. So why we go for different? So basically, like so our transactional data, that transactional data in Walmart, that comes through SQL, and there is a NoSQL. Say for example, the product information, the product catalog that we sell, so that is actually stored in a NoSQL database. And if you see like the way that the number of users, the historical data that we have, how they are actually participated, how their purchases to everything. So those data we store it in, HDFS, not in S3. We are going to, we are using in a different cloud environment. So this is just to give you an example of, how different storage format. So taking Walmart as an example, so we have these many use cases. Okay, so we have a requirement in which we need to connect to any different data source that we have. So H2O provides a way to connect that. Okay, and the core components of H2O, if you ask, so there is one thing called in-memory map reducer as well as memory manager. So the in-memory map reducer is basically a distributed fork join operator. So I think you might know what is the map reduce algorithm. So map reduce algorithm is introduced by Google in 2004, which is predominantly changed the way of distributed data processing. So that is using that map reduce concept on the in-memory database to make sure that the iterative program or the iterative algorithms that we run can able to use this in-memory map reduce to compute our machine learning. For an example, consider a decision tree. Okay, so we know decision tree is a iterative algorithm. So we go for we select one particular leaf node, and from that leaf node or from that class label, we keep on creating the entire decision tree to perform a classification task. So when you perform multiple iteration over and over again, so one iterative, like the previous iteration results needs to be given to the next iteration. So when the second iteration computes on a different worker, so how do you ensure that the previous worker results gonna be shared? So that is being broadcasted to all the other workers. So those set of powerful features that built in H2. Okay, and the next one is memory manager, which is basically a columnar compression. So what is this memory manager? So when you bring your data into a model, so we know what is a model in machine learning, right? So when we create a model, so the model itself might be huge in some cases. In some cases, it will be like a small equation will come, or a small a formula that is also might come. So that data, how do you store it in a columnar format so that your distributed system can process it? Okay, so this is like, like our important part of H2O. So with respect to what are the algorithms that we wanted to run, so let's say, for example, let's say you want to use deep learning, a neural net for clustering, classification, regressions, or anything. So basically this provides ensembles of our machine learning models or deep learning models. So on top of these two things, so where they have one thing called as rapid query R engine to basically to query the results on R programming model. And they also have something called nano fast scoring engine. So what do you mean by scoring engine? So in a machine learning and deep learning world, if you see, there are multiple ways you can score a model based on their root mean square error, based on their, confusion matrix, and so on. So when you score a model that, this model is works, if you score a model based on these parameters, so that scoring engine they have built for nano fast second, so that you can actually no need to spend much time on deciding what model you want to use for your data. So finally, they provide an API for us to use in any of this programming language like R, Java, Scala, or Python, or etc. Okay, so this is an example of how H2O they have introduced it in uh, Amazon Cloud, on-premise, Hadoop, and all those things. What are their data size, etc. So let's see what are the algorithms that are offered by H2O. So H2O, as I said, it's a framework as well as it's a platform. When I say a framework, it has an inbuilt code of running these algorithms in a distributed fashion. Say, for example, supervised learning. So I don't want to talk about what is supervised learning here. I hope that is fine. If not, just let me know. I can just introduce what is supervised learning and we can go. I hope that is not necessary for this audience. Am I okay on that?
Yes, sir.
Okay, thank you. Thank you for the response. Okay, so as we know that, so supervised learning, so like these are the some of the models like GLM, like generalized linear models. So we can go with the binomial, Gaussian, gamma, Poisson, or TVD. So these are the different algorithms to run for GLM. And Cox proportional hazard models, naive Bayes, distributed random forest, GBM, deep learning, all these things are part of supervised learning. So these are statistical analysis, these are ensembles, and some of these are deep learning. So again, coming to unsupervised learning, so they have k-means, PCA, and autoencoders. So this is a comparison of H2O benchmark. Okay, so when you run it with a normal engine and the same with respect to the traditional Mahout processing, how it is actually taking. Okay, so this is, we have a billion row data. So in the billion row, it's a big data. So for that big data, you are trying to run a GLM logistic regression with a traditional distributed processing like Apache Mahout, and you are comparing that with H2O. So it depends upon how much of parallel nodes that you are adding and the parallel memory that it has. So the computation time as well as the model building time and all these things are reduced very significantly from this screen. So this is actually, to give an example, this is an airline data set which consists of 42 GB CSV, has 1 billion rows, 12 input columns, and one output column. So it's a numerical column. So they are actually doing a regression. Okay, so regression on the cardinality. So since it is running on a very huge data with the traditional Mahout, so there are some complications where it might break in some of the executors, and finally you will get it on, in some hours. But when you do the same thing on a distributed H2O engine, so this is an example of H2O running on 16 EC2 nodes, 16 into each machines as 8 cores and 15 GB RAM per machine. So which are connected as a client server model or a master slave architecture. There we are running it. Okay, so similarly, again, the same thing, it took like 14.9 seconds for 3 iterations for both numerical and categorical data. And like 16.5 seconds for 2 iterations on numerical. And when you increase the number of nodes, you can significantly see the performance of how much time it is taking to build the entire model. So that is how exciting H2O is. Okay, so let's come to another tool, so which we have something called as H2O flow. So before going to the tool, actually, do you have any questions on the architecture or the algorithms that is supported, or the benchmarking? Any questions? If anybody has, you can speak out, so I can answer your questions immediately, so that this session can be both interactive as well as kind of a knowledge sharing. Instead of a one way, let's keep it both the ways. That's it. Any questions from participants?
Any queries you can ask in. Otherwise, we could have the question answer session at the end, towards the end, sir.
Yeah, sure. I mean, like so far, I'm just checking because like
Sure,
this
sure,
is
sir.
the fundamentals of what is H2O. So if this
Okay,
is
sir.
understandable, and then we can proceed directly. Okay. So
So
I hope.
there was a one query to me privately sent whether a data set of 1 billion can run on an Android app. So the question was asked by V. Arunachalam.
Okay. Okay. So 1 billion rows can run on a come again. What?
Android app. If a data set of 1 billion, whether a data set of 1 billion can run on an Android app.
Okay, so here I think some context is missing. So when they say Android app, an app is just an interface. Okay, whether it is running behind the scenes in a server or a cloud, or whether it is running on the Android phone itself, it is different. So maybe I just need more clarification on that question. So there are two ways also. So say for example, there are traditionally, like if you see, right, so there are actually pre-executed, I mean predefined models can be installed on your mobile phone. No need of any additional compute is needed. That model can able to do image recognition or any of your text recognition, etc., because that model is built with your mobile size itself. But if you want to build a new algorithm altogether and you want to create a model out of it, that cannot be done on an Android for 1 billion rows. I mean to say on one Android device, I mean to say with one mobile phone. But once you build the model, and you can actually convert the built model to your Android system so that you can use that for predictions. Did I answer that question?
Right, sir. Thank you. That was
Okay.
only query posted to me.
Yeah, actually, the question can be posted to everyone so that, I think even if I see any of this question during the session, I'm okay to answer it on the floor.
I don't know. Somehow the public chat facility is disabled. I'm not able to enable it also from my side. So the questions, whatever is being posted, is coming to me privately, to the host privately.
Oh, okay. Yeah, actually, yeah, I think from G Raju also has post how to use this type of tools. Yes, that's a very good question. So that is what my like upcoming slides are going to be. Okay, so I think, yeah, so let's get started. Okay, so now I'm going to demonstrate how to set up H2O on your computer and how do you run that H2O for a sample data set. Okay, so when I say time series data, right, so basically we are not actually going to use image or speech or text to use our deep learning. So that is also a domain that can be used your deep learning. But there are some nonlinear data set like the way we use in our everyday life at Walmart. So we actually get a lot of time series data. So we use this time series data, to process this data uh, and create a model out of it. And we use this model directly for our forecasting and forecasting of a demand and all those things. So let's introduce the first tool in our H2O, which is something called H2O Flow. H2O Flow is a simple web interface. Okay, you can simply run it. You can download a jar from an internet, and you can run it on any operating system. It could be Windows, or it could be from a MacBook or a Linux machine, anything. So it provides you a web-based environment, and it is actually an environment for you to easily play with any of your copy script or text or markdown or any of model comparisons, etc. Okay, so let's see this. So I will go through H2O Flow, and we'll see a demo of how we can run a sample algorithm on H2O Flow, and then we can proceed further. Let me stop share the screen and I'll reshare the again to download the H2O Flow. I'm just sharing my whole screen so that you can see what is going to happen. Yeah, I hope you able to see all of the screen, right? So yeah, so these are the some of my notes. Just don't worry. So first thing what we are going to do is, so we are going to download H2O Flow directly from our internet. So you can download it from the internet, H2O Flow. So you will get actually this page called downloading and installing H2O. So this version is 3.32. So there is a download page. So you can go to that download page and we can download this. So if this is a link, I can send this link in our chat window so that you can see this. I'm posting it to everyone so that if anybody wants to try it, right, so they can go and download it from here. So once you download it, right, so I already downloaded it. just to make sure that, not anything is happening. So I'm opening a terminal. So I'm already in a terminal. So the download is already in a downloads folder. I'm just changing my directory to downloads. So there I have something called H2 folder. So H2 3.30. So here it is 3.32. So there is two minor versions got released after a few months, but it's not an issue. So we can go with the 3.30 also. So I'll just go to H2O 3.06. So this, when you download it, whatever the downloaded you have, it actually has a jar and it has some Python bindings, R and etc. So what we are interested is, we are interested in only running this jar. So since it's a jar, we need to use a Java command to run this. So the command is going to be java -jar space, the jar name is h2o.jar. So you can refer these commands directly in the link that I've shared. You can, the same is applies here also. So as soon as you enter this command, java-jar space h2o.jar, you can actually see, right? So it is actually trying to use all the memory that is available from my computer and all the cores that are available from my computer. So machine physical memory is 16 GB, as you can see. And what is the total heap size? What is the max heap size all assigned here? And how many cores that are available in my machines, and how many cores are registered for this use, etc. Okay. So now the H2O flow is started, and we can just use this URL to run this. So I'm just opening another tab and entering this URL. So this URL will open a H2O flow window. Okay, are you able to follow me so far? So I'm repeating the steps again. Whatever the link that I've shared, okay, so download the H2O package. That will be a zip file. After you unzip it, you will get a jar file. Use this command to run the jar and open the local host or the IP address, whatever that came over in your command prompt, copy it and run it, and you will get it in your browser. So one prerequisite for this is you need to make sure that Java is installed and set it into the environment variable so that your Java can run from any path. So that is one thing. Okay. Any questions so far? If you have any question, just add it to the chat window. I can answer it immediately. So now what I'm going to show you is, I'm going to show you a sample way. How do you use H2O flow? And using H2O flow, how easy it is to run a machine learning or a deep learning algorithms. Actually, for this demonstration, I cannot actually use a distributed environment to showcase, but this is a simulated tool where you can run it on a single machine. But once you productionize it, you can run it on a distributed engine using another tool called Sparkling Water. Okay, cool. So this is the H2O flow browser. Okay, so this, if you see, it looks like a desktop application, but it is not. It is called as a window-based application. And so if you see here, um, just a minute. Sorry, there was some interrupt from office, so I could not avoid this. So basically, if you see from this flow, right, so we have something called as H2O flow. This is a web-based tool. You can actually create whatever your workflow. Let's say, for example, here a sample uh, deep learning example. I'm just creating this as a H2O flow. So here, the coffee script that I was talking about, right? Coffee script or Markdown. So this is called that script. You don't need to learn the script to use it, but internally it uses coffee script to run it. But this provides an assistance. You can just click on it, with comes with the UI. You can just use that UI to run anything. So step one, what I'm going to do is I'm going to use this something called import files. Okay. So basically, I am going to use a data set which is available from an internet source. I think I'll share you that data source path. So this is actually, if you see right in this GitHub location, they have an examples and example data sets also given. So we are going to use the same examples. So this is the link that I have. So you can download this code and you can use it. I'll share this. So you have something called examples here. So in the examples, they have something called small data. So inside this small data, they have a lot of example data sets, loan, insurance, birds, etc., etc. So we can use any of this. So I've already downloaded this file, and the file is already available in my folder downloads. So I have this sparkling water. So here I have the examples. So here in the small data, you can see the same data set that I have it in my computer as well. So using this data, let's do some analysis. Okay. So there is a data set called loan.csv. Okay. So this loan.csv as some call, let's see how many columns that it has. Now we want to make sure that whether he is eligible for the loan or not. Okay, so this is a column that we want to see. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So totally we have 15 attributes, and almost we have some 1,000 plus rows. Okay, so the attributes we have like loan amount, term, interest rate, employment length, as he own house, how much of annual income, so what is the purpose, what is the address. Actually this data is collected from United States, so the state codes looks here or United States code, Arizona, Illinois, etc. And DTI, what is that, 2 years, what is the revolution until, so bad loan, anything. So based on this, so they have they have a target column, whether it is verified or not verified. So this is a good data set for doing a classification. Okay. So let's use a neural network, like a deep neural network, to use for classification of this time series data. Okay. So this is the data set that I have. So now I'm going to H2O flow. Okay. So it is asking the file. So the file, it is actually enter a file or directory path and then press enter key. So this file path that I have, it is actually inside a directory. I'll just go right click, get information. So this is the location that I have. So I'll just copy that location. So, and then here I'll paste it. So as you can see, so this is the location, users, my user ID, downloads, examples. So I'm going to select loan.csv. Okay. As soon as you press enter, right? So the file is selected. Okay. Once you select the file with your mouse, so there is an action will be available for you to import it. So let's go ahead and do the import now. So what it does is, so we actually used an assist from this import files. So this opened an interactive UI user interface where you to upload your file, select your file, and then click import. So that automatically converted a coffee script, import files of this path. So this is a code equivalent for what we did so far. So second one, since it's a CSV file, so there are some pre-processing requirements needs to be done. So those pre-processings are nothing but you have the file with you ready. Now let's just click this parse these files. So what will happen is, since it's a CSV is a comma separated file, you need to specify what is the parser that you want to use. Because the overall how H2O flow works is H2O flow will try to convert the data from your file into a data frame. That data frame is nothing but a table. So that data frame table is what we are actually going to use over here. So the data is stored as .hex .hcx extension. So we are going to use CSV, and the separator is going to be comma, and the ASCII equivalent of comma is 44. That is also fine. And now you are specifying. So from your CSV, as you can see, I have a header also in my CSV. So what you can see, first row contains column names. So you have to specify that whether you have header or not. So I have a header, so I'll select this. And you can actually see that, right? So these are the 15 columns that are available. And each column, what is the data type? Is it a numeric column? Is it a categorical column? Or is it a textual column? So all these things being recognized by the H2O flow itself. Okay, and you can actually see some preview of this data for this 15 data set. It's actually a matrix. So over here, it is transposed from row side to column side. So that's why it is looking a little bit different. Okay, so let me give a parse. So as soon as you click parse, what will happen is it will convert the file and it will create that file into an in-memory data frame. So that in-memory data frame is ready for you to run your deep learning algorithms on top of it. Okay, so as soon as you click parse, so there is a coffee script similar to that, okay, which came here. And you can see the job ran in 263 milliseconds. Excuse me, I just need some water. It's been like a long time that I'm speaking this much, so just it's getting breaking my voice. Okay, so let's do parse this file. So as soon as you parse the file, you can actually now data frame, right? So you can see. So this is the data frame. So you are actually getting your data frame summary. Okay. So how many labels are there? What are the types, and how much of columns which are missing? How many zero records are there? What is the min, max, mean, standard deviation, cardinality, etc., etc., etc. So if you want to perform anything, you can actually do it. Okay. So now you can use these actions on this data frame. Okay. One is called view data. So view data is what you can actually preview a top 20 records, okay, or top 100 records, depends upon the length, and you can actually see the data, what we saw from this Excel sheet here. Okay, so there is another action called split. So split is an operation where you split how much of data that you want to use for training as well as testing. So it usually the ratio is going to be 75-25 or 70-30. It depends upon you. Okay, so you can specify, your ratio going to be 75-25. Okay, and what is your seed value? Some seed value randomly it will split, and it will create another data frame. Okay, so there are now two data frames are available. So which is training data and frame for testing data. So we can use any of this for our training and testing purposes. So next one, there is a third option called build model. Okay, so what is a build model? Now we are trying to fit a model for classification. Let's say we are going to use a decision tree classification for this. So how do you build this model? So just click on the build model. So it is asking you to select an algorithm. So what algorithm you want to use? So as I said earlier, let me go with a decision tree. So but decision tree is a normal tree, but when it comes to native to H2O, we have actually distributed random forest. So what is the difference between a decision tree and a random forest? So random forest is like hundreds of decision trees. So that is what we call as a forest. And we run this random forest algorithm on a distributed fashion. So this is not a deep learning. This is simple machine learning example we are running, okay? And finding, see how much of accuracy it is. And then we can use the same data set to run a deep learning algorithm to see how much of a change is happening. Okay. So once you've selected your algorithm, so I've selected a distributed random forest. Now it is asking me to select a training frame as well as a validation frame. So training frame, you can actually choose like whole data you are using it for this one, or we have already split the data into 75-25. You can use that also. For this sake, I'm going to use the whole data set as it is. For validation frame, if you want to validate your data, where against you want to validate. So this is going to be like optional. So I'm not going to choose it for now, let it be. And how much of number of folds that you want to happen. So this is with respect to random forest, this property. So number of folds or a k-fold cross validation we want to do. So if it is 0, you don't want to validate it. And the important one option is you want to select what is your target label or what is your target attribute that you are going to predict it. So as soon as you select, so there are a lot of columns that have some noise data also. So during pre-processing time, what we do is, so we actually, during our pre-processing time, we actually um, remove some of the columns of in our data. Okay, but if you want, you can remove some of these columns. If not, you can just go ahead and process. So how many number of trees you want to create in your random forest? So I'm going for 50, and how much of max depth you want, how much of bins, how much of seed, how much of M tribes. So these are very specific to random forest. And yes, my agenda or my motivation is not to introduce you random forest and how this algorithm works, because you are already know how that works. I'm introducing a tool so that you no need to spend your time investing on how to write a program to solve that. It is already available so that you can use it to validate your findings and your things. So since, as we know, this random forest is an iterative algorithms, you can go for any score. If you want to score, what is the value you want to choose, all those things. So these are going to be very advanced. So you can read about it, you can understand it. So this is very specific to random forest, and you can apply the value. Okay. So finally, let's click something called build model. So what will happen? It will take some time. In this case, it took only like 1 second, 1.5 seconds. It's not even a couple of seconds for this 1,000 records, and it built a model. So the model is available here. If you click on view, so this is the model that is built. Okay. So now we can see the scoring model parameters and all those things. So what is the model? What is the training frame as used? What is the response column? And what is the distribution that has used, etc., etc. So this is, you can see how much of a log loss has happened. This is ROC curve. This is, your variable importances, which variable is, importing more. And this is your confusion matrix, how much of false positives or false negatives are happening. So based on that, you can actually use precision recall to score your model and to gain, like, to know about more those things. That's it. So we built a model and the model is ready. And as soon as you build the model, since it's a Java programming model, what is offering this H2O flow out of the box is you can actually download a code for the same model, into a Java program, so that you can just use this Java program plug and play into your any of your like low environments like Raspberry Pi or mobile devices or anything, where you can simply run it to test it. Whether if I come with these set of columns, whether the loan status is needed to be verified or not verified to to give an approval for them. Okay, so you can see this is a Java program. So this Java programs comes in with all the variables. So what are the columns that you have? And so this is the decision tree algorithm. So that is finally built, and the algorithm is ready for you to use it. Okay, and even you specify, right? So the maximum depth of your tree is going to be 20 or 25 something. What is this being set? Based on that, the condition is also being generated directly by the H2O flow. So this is a sample machine learning algorithm running on H2O flow. Any questions so far? Or am I going too fast? So please let me know so that I can reduce my pace.
Any queries, please?
Okay, so is it interesting? I mean, I thought, like, is it something that you might be wondered about to see, like, whether these things can be done such a simpler manner. So that is what my intention is today. Anybody felt like that? So that is my my takeaway from this session.
So there's a question from M. Vijayan. Will H2O support any algorithm for image processing?
Yeah, see, H2O, the overall as it supports. So, but right now, this session is particular to time series data. Yes, it can support. It can use for even other domains of data like image and video and textual, speech also. But with H2O flow, you cannot use it. H2O flow is specifically meant for big data and time series related data. Any other question?
Please proceed, sir. That's it, sir.
Okay. So this is an example of, a machine learning algorithm. So how it is run. So let's see, let us run a deep learning algorithm. Okay. And use the deep learning algorithm to run the same, the problem which we had, which is having the loan data set. We used to run a different model now. Okay. So now what we can do is, you can actually save this. Okay, so this save will be available on sample DL. I'll just change to, sorry, CSV data random forest. Okay, let us create another one which is going to be flow. Let's create a new flow. So this will be created into a new one. So here, so I think we have to go with that same command, import files. I think F should be capitalized. Okay, so import files. So you can actually open that assistance also for you to see how this is running. Now I'm again selecting the same file, loan.csv, enter, select import. Okay, so this converted into import files. Click on the parse. So I think I know all these arguments gonna be same. Clicking on the parse. So next going to be, so we have selected the file, and then what we are doing is we are clicking the view option. So you can see the data. So now instead of splitting all those things, I'm just going with a build model. So this build model, okay. So what algorithm you want to run? So now let's use a deep learning algorithm. Okay. So using a deep learning for classification. Okay, so again, it is asking me to use a training data frame and validation frame. I don't want anything. So if you want a response column, this is very important. We have to select validation. So we know what is deep learning, what is perceptron, what is multi-layer perceptron, like how individual components of neurons, neural network works. I hope everyone understands that. So using those concepts, using this web UI, we can able to build a deep learning model in less than 2 seconds. So that is the intention here. Okay. So as one of the important factor of a neural network is an activation function. So what activation function that you're going to use? So whether your activation going to be rectifier or whether it is going to be tan edge. So tan edge is like as you know, right, the numbers like 1 divided by 1 over e to the power minus x depends upon the value. So whether you want to use tan edge with dropout or without dropout, so all those things, it's an option that we can choose. So I'm going with a default activation function, which is rectifier, or even there is a one more activation function which is now famous called ReLU. Even we can use that also. Okay, so how many hidden layers, of your neural network should be? So this is 200 hidden layers. Okay, so the number of hidden layers, when you increase, the time it takes to build your model also will get increased. So that is the analogy behind it. Okay, so let me go with the standard 200 layer size, and all these advanced, I'm not going to give anything. I'll just click on build model. So what is happening is it is actually creating a model in less than 2 seconds. So it took, like, distributed random forest took 1.5 second. It took 1.983 seconds because deep learning computation is very different than random forest. So that is the reason of time difference. So let's go with now, instead of what we have specified 200, let's provide 500. So I'm increasing the number of hidden layers. So as you increase your number of hidden layers in your neural network, so the time it takes to build your overall model also will increase. Okay. See, so earlier it was like 200 hidden layers. Now I have 500 hidden layers. So for this 500 hidden layers, so the time it took is 3.8 seconds. Okay. For a normal 200 layers, it took like 1.983 seconds. So now, as you can see, the model has built. You can click on view. So this is the model of a neural network. Okay. So like these are the neural network metrics. So confusion matrix came for random forest, but confusion matrix won't come for neural network because that is not the math model of neural network. So depends upon that, you will get a different scoring system. Again, you can go for a preview of Pojo. So Pojo, it will be like how your neural network is calculated of all these iterations with your activation functions, etc., etc. The matrix calculations, all things are given here. And what is the weight is being assigned to every neuron. Okay, so that is what the neural network concept is, right? You adjust the weight as you iterate over to the data set to come up to the desired output that you are looking for. So these are the values that the rectifier layer has generated. Okay. So this is over. Now what we can do is, now we build the model. Let's do a prediction. So let's click on predict. Okay. So prediction. So prediction is going to be for a specific data frame. So I have chosen the entire data set, which I have 1,000 records as a overall data, out of which 25% of data randomly selected. Using that 25% of random data, I'm going to test my own model. So how much of accuracy it is coming to see that. So I'm selecting the 25%, and then you can click on compute deep. How many hidden layer you want? Go with 5 hidden layers so that your computation will take some time, but it will come to a good result. Sorry, I think for this it's not required. So I mean, for this use case, it is not required. So if you see here, So the hidden layers is exact must be 0 and 1. Okay, you can give between 0 and 1. So I'll give 1 and let's do a predict. Okay, you can actually compare without providing and with providing. Okay, so after your prediction, then only you will be able to see how much of your domain not verified, how much of verified has come. So, and as soon as you predicted, so you can actually see all of your errors, Gini index, everything from this. Okay. So basically you can see combined prediction with your frame. So you can actually compare it. Okay. So when you combine it, right, so you can actually see what is the data and like how much of data it is coming and how much of data it is missing. So all those things also we can see from here. Okay, so all over this is a very really intriguing tool for you to use and to explore data. So there is this is just for data enthusiasts to understand, to apply a machine learning and deep learning algorithms to check how the data behaves first of all. But then there is another problem comes in where I'm expertise. So we're using this model. So this is building this model. It is going to be like 1 day or 2 days work. But this model is continuously running like once in 24 hours, once in 6 hours or something. For that, we need to provide a sufficient infrastructure to run. So that is what my expertise is. Okay. And using these algorithms, these tools, which which I inherited from my masters, I'm presenting it over here. Okay. Any questions? So how is the H2O flow tool? Is it good? Is it bad? So you can share your feedback here, and then maybe we can move on to the next one. Okay. So from I think I got one more question from a participant. Can we get a Python code for the same tool or just a Java program? So currently the H2O flow is supporting only Java. But if you want to convert to a Python, that is simpler only, but right now it is not supported. Any other questions? So you can actually you can export your data frame. So whatever the data frame that you got it into a file or a table or anything. Let's say, for example, you are going to export the overall combined frame from a path. So I'm just adding another variable called output on the same small data folder, clicking on export. So what it will do is it will create this data set on that path, and you can see that. So from this, so you can see previously in small data, there was no output, but it actually just got created at 2:28 p.m. today. So now we can actually open with text editor, we can open with any of these things. So we can actually see how this data looks like, because it's a CSV data in combined form so that you can process it. Okay. So if let's say if I'm comparing with the normal data, I think that will be helpful. Let me go with loan.txt itself. I'm just adding with loan output.csv export. Yeah, so you can see loan output CSV. Let me open that. See, this is going to be the exact same data that I entered. Okay. Okay. Any questions so far? Okay. let's go to the other one, which we have it here as this one. So this is the H2O flow code that I was talking about. So coming to the overall H2O software stack, so there is, so right now whatever we used, which is a standalone H2O, it is not a distributed one. You can use this distributed engine also, that is also supported by the H2O software stack framework. And these are all the different algorithms which are supported by the H2O system as well. Okay. So the one more, so basically as a data scientist, deal with the data is basically they deal with the data directly from reading from a path they will create. So let's say, for example, the user is an R user, is trying to import a file. Okay, so from importing that file, the data.csv or where, how this is being distributed and run it into parallel, right? So that is what it is actually. So it creates a function called to read the file and use HTTP REST API to transfer the data from HDFS into your local path within your H2O cluster, so that the data will be get distributedly ingested on all of the H2O workers, and this will be read from your HDFS storage. Once that is read, right, this data will be converted into H2O frame. That H2O frame will be returned to as a pointer to the H2O to the user, so that the user can able to view it. When you click view from the option that I've done it, right? So that is also going to be similar. Okay, so this is like how the TLS or the transport layer security, how this implementation going to be. So step-by-step process. So basically, like you have R script. So from the R script, you're actually calling this h2o.glm. But behind the scenes, it is using a REST connector to build a model on GLM. So that is communicating through an HTTP REST, the JSON format on a network. So that is actually going to the H2O process, where you have using the fork and join framework. And there you have your GLM task, GLM algorithm, your job, and finally you will be using the endpoint to run it. And once your data is written, so using the KV store framework, you are returning the results back to the same flow where it has written. Okay, so this is another a tool called H2O sparkling water. I think which we don't have enough time to cover it. Maybe like if this is an interesting tool also to use Apache Spark with H2O. Okay, so if I think if any of our researchers wants to go through it, you can actually go through this H2O sparkling water. So that is also an important. Yeah, I think we have finished it more before what we expected. I think let's open up for questions now, and let's see. Hello.
Participants, any queries, you can get it clarified.
So, I mean, even if you can share the feedback about this session, like how do you feel about H2O, right? So that is all.
Good afternoon, sir.
Yes, sir.
One more doubt.
Yeah,
Hello,
please
sir.
go ahead.
Can you hear my voice?
Sorry, come again.
Can you hear my voice? Sir,
Yeah, I can hear you.
okay. If the framework support for bioinformatics dataset, sir?
No, I think we lost you in the middle. I could not hear you.
So he wants to know whether
Can
the
you
framework supports for bioinformatics data sets. Does it support bioinformatic data sets? And
Yeah, I mean, bioinformatics data sets, I mean, if it is a drug-related data and protein synthesis, something, right? And if you want to use a normal, like standard statistical calculations, you can use it.
Okay. Thank you.
Okay, ma'am, I think if there is no question, then I'll...
participants, any more queries, please? Any more queries or clarifications?
Okay, if you have any questions also, right, you can actually run it on, you can send it to my email also. I'll share my personal email ID. So you can reach out to me also. I'm just putting it on a chat window. If you want to have any questions related to the session, I'm happy to answer. So how to use H2O platform in Walmart data? So currently, I'm not using H2O platform, or even in some of our Walmart cases, but that is confidential. I cannot tell how it is, but you can use the way that I've explored. I've experimented. Okay.
Any more queries? Can we wind up?
Yes, ma'am. I think.
Just a second, sir. So thank you, sir, for accepting our invitation and consenting to be the speaker for the afternoon session. So you have introduced us to H2O flow and sparkling water. The name itself had generated a lot of curiosity. It was basically the open source machine learning platform that makes it easy to build smart applications. So hope all the participants have got benefited out of it. So on behalf of the Department of Computer Science and Engineering, I present a digital certificate to Mr. SasiKumar Venkatesh. So are you able to see the certificate, sir?
Yes, ma'am, I can. Thank you.
Thank you very much, sir, for your time and effort. It was a very fruitful session.
Yeah, thank
You,
you very
in fact,
much.
introduced us
Have a good
to
day.
two new technologies in AI and deep learning. Thank you.
Sure, ma'am. Thank you. Bye.
So the feedback link will be shared with the participants. Kindly fill it. So the response form will be open for half an hour.